If x plus 1 by x is equal to 3, what is the value of x squared plus 1 by x squared? What about x cubed plus 1 by x cubed? And then finally, x to the power 5 plus 1 by x to the power 5. So let's start with the first problem, which is finding the value of x squared plus 1 by x squared, given x plus 1 by x is equal to 3. If we square both sides, we start from x plus 1 by x is equal to 3 and we take the square of both sides. On the right hand side, we have 3 squared, that's 9. And on the left hand side, we have x plus 1 by x whole square. Now, here we reference the formula for a plus b whole square. So if you expand a plus b whole square, this is what you get. A square plus 2ab plus b square. So this is something that's good to memorize or remember. Now, if we substitute x for a and 1 by x for b in this formula, then this is what we get when we expand the left hand side. X squared plus 2x into 1 by x plus 1 by x squared. Now, this term, x and 1 by x, gets cancelled and we are left with 2. So if we change sides, if we take the 2 to the right hand side, then it becomes negative 2. So we have on the left hand side x squared plus 1 by x squared, and on the right hand side we have 9 minus 2, that's 7. So the value of x squared plus 1 by x squared is 7. Now let's come to the second part of the problem, which is finding the value of x cubed plus 1 by x cubed given x plus 1 by x is equal to 3. This time we start by cubing both sides. So we have x plus 1 by x whole cube is equal to 3 cube, and 3 cube is 27. Now, if we expand a plus b whole cube, so that's kind of another formula that might be useful to remember, especially for problems like this. So we have a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Now substitute x for a and 1 by x for b, and if we expand, we'll get something like that. X cubed plus 3x squared into 1 by x plus 3x into 1 by x whole square plus 1 by x cubed is equal to 27. Now, if you look at the two terms in the middle, x squared multiplied by 1 by x, so the x in the denominator gets cancelled out, and on the numerator we are left with x. So that will be 3x. The first of those two middle terms will be 3x. And the second of those two middle terms, we have a multiplication of 3x into 1 by x whole square. So the x in the numerator gets cancelled out and we are just left with 1 by x in the denominator. So we have 3 by x. So the middle two terms will come to 3x plus 3 by x. And if we take 3 out, we'll get 3x plus 1 by x. Now, we already know what x plus 1 by x is because that's given. That's 3. And 3 multiplied by 3 gives us 9. Now, if we take 9 over to the right hand side, it will change sign. So it will become negative 9. And we'll have something like this. X cubed plus 1 by x cubed is equal to 27 minus 9, and that comes to 18. So that's what the problem asks. What's the value of x cubed plus 1 by x cubed? So that's 18. Now, what about x to the power 5 plus 1 by x to the power 5? Well, we can potentially, start by taking the fifth power of x plus 1 by x, just like we did for the first two parts of the problem. But that's a little bit longer and a more laborious method, and you really need to know, the binomial expansion, for these higher indices or higher powers. But there is actually a much easier way of solving this problem. Now, in the first two parts of the problem, we've already solved what x squared plus 1 by x squared is, so that's 7. And we have also found out x cubed plus 1 by x cubed, and that's 18. Now, if we multiply these two, so when you multiply higher powers, the indices will get added. So x cubed multiplied by x squared will be x to the power 5. So if you do the multiplication term by term, which is relatively easy to do, this is what you are left with. X to the power 5 plus 1 by x plus 1 by x to the power 5. And 18 multiplied by 7 is 126. So that's what we have on the right hand side. Now, we already know what 1 by x plus x is. So it's the same as x plus 1 by x, and that's given as 3. So we take that. So we are left with x to the power 5 plus 3 plus 1 by x to the power 5. And on the right hand side, we have 126. So from this, it's easy to note that x to the power 5 plus 1 by x to the power 5 will be 126 minus 3. That's 123. So that's how we can solve x to the power 5 plus 1 by x to the power 5 without going for expansion of x plus 1 by x whole to the power 5 and using binomial expansion for that. So that's another way to do that, but I think that's a more laborious and definitely a longer route to solving this particular problem. Now there's another problem which is kind of similar. If x plus 1 by x is equal to 2, now the indices are really enormous. What about the value of x to the power 2020 plus 1 by x to the power 2020? So this problem may really seem daunting. It's a little bit different, of course. In fact, we'll see that this is a whole lot different. The approach here is a whole lot different than what we have done for the first three parts of the problem. For this problem, it doesn't make sense to actually go for, the higher power expansion of x to the power x plus 1 by x, because the power is really huge. It's 2020. Instead, we can try to see if there's a way we can find out what x is given x plus 1 by x is equal to 2. So if we multiply both sides by x, and since we have 1 by x given, we are assuming that x is unequal to 0, so we can multiply both sides by x. And we get x squared plus 1 on the left-hand side and 2x on the right-hand side. And now we change sides. We take 2x to the left-hand side, so that becomes negative 2x. And we have x squared minus 2x plus 1 is equal to 0. Now this term, x squared minus 2x plus 1, so this is actually x minus 1 whole square. So x minus 1 whole square is equal to 0, which implies x is equal to 1. So now we have actually solved with the value of x, and x turns out to be 1. And we know that whatever the power of 1 is, it will still be 1. So it doesn't matter if it's 2020 or 2019 or anything for that matter. So x to the power 2020 plus 1 by x the power 2020 is 1 plus 1 equal to 2.